Hello everyone. So today we in this lecture we are going to see about the transportation model by Northwest corner method. So first we will see what is the transportation model. It is the model which determines the schedule for transportation of goods from sources to destination in such a way that it minimizes the shipping cost and satisfies all the demand and supply constraints. As we all know, the transportation problems are of two types, that is balanced and unbalanced. But to solve this method of transportation problems, we have three types, that is Northwest corner cell method, Google's approximation method, least cost cell method. So first we will see about the Northwest corner method. Here the question is given that raw materials are to be allocated from the 4 different warehouses to 5 different plants. The availability of the raw material in the 4 warehouses are given in tons, that is 25, 30, 20 and 30. While demand of the raw material in the 5 plants are also given as 20, 20, 10 and 25 tons. It is not possible to shift the raw material from warehouse number 4 to plant 4 because of steep road from the unit cost of transportation. This is the constraint they have provided. So let's find out what is the optimal shifting raw material to the plants and the minimum cost we get by considering this constraint. So we have prepared the table where P indicates the plants and W indicates the warehouses. So the first step is to check whether the problem is balanced or not. So to check the problem is balanced or not, we have to add all the demands and all the raw materials. That is, summation of material supply is equal to summation of demand supply. Here both are of 105, hence the problem is balanced. Next, so we are going to select the northwest corner cell to solve the problem. So in this given matrix, the northwest corner cell is of P1 and W1, that is 10. So let's see how to solve. So here we have given a blank matrix where supply and demand are fulfilled. So for P1 demand is 20 while W1 supply is 25. So we can fulfill at least 20 demand, that is all demand for the plant 1. So supply remains 5. In the next matrix we can see again the northwest corner, as we have not considered P1 where demand is 0. So the northwest cell for the remaining matrix will become W1 and P2. So it is 5 where supply is fulfilled but demand is remaining 15. Hence in another slide we will consider the remaining matrix where W1 and P1 are not considered for their 0 demand and supply. The northwest cell will remain W2 and P2 where the demand 15 get fulfills while supply 15 remains as it is. So in the next matrix, P3 and W2 is the cell of the northwest while the remaining matrix is considered. So we will fulfill all the supply of 15 and demand from 30, which will remain the 15 demand as it is. Hence in another slide we can say for the remaining matrix P3 and W3 is the northwest corner, as we have not considered W1, W2, P1 and P2 because of their 0 demand and supply. Hence the remaining cell is P3, W3 where the demand of 15 get fulfilled from the supply of 20, which remains supply of 5 behind. The next matrix where the northwest cell will of course remain as W3 and W4, as W1, W2, P1, P2 and P3 are not considered, where supply of 5 get fulfilled from the demand of 10, where 5 demands are remain back. In the next slide we have got the northwest cell as W4 and P4, where demand of 5 is fulfilled from the supply of 30 and 25 supply are remain back. The next slide is of the remaining one, that is P5 and W4 cell, where 25 demand and 25 supply are remains, hence the problem gets over here. But as they have asked the optimal solution for the problem, we have to calculate the initial basic feasible solution, that is IBFS. Hence, to calculate this, we have to take the first table given by them and the matrix cells fulfilled by us by NorthWest corner. To take this, we can take W1P1 as 10 and W1P1 as 20. We solved. So 20 into 10 plus, like that, all other cell P2 W1, P3 W2, all. The summation of this all gets 1030, and hence the initial basic feasible solution for the transportation problem by NorthWest corner method, where optimal shifting of raw material is to be rupees 1030. Thank you.